This is the final video presentation for the ME 2110 competition for Group 3 in Section J. Here are the tasks the robot must complete in 40 seconds. After 3 minutes of prep by the team and a size check of each robot, the competition begins when the TA shorts the banana plugs of the 4 robots that are competing. The first task is to retrieve Buzz. Here, the pizza planet is the red circle. The green aliens must stay in place within the circle while getting the blue block representing Buzz out to safety. Half the points are awarded if Buzz leaves Pizza Planet, and full points if he gets back to the start zone 14 inches away, which is highlighted here. The rotating cylinder in the center of the track has a blue minivan on top. The task is to put a ball in the open roof. However, our group decided not to pursue this in order to successfully egress. The cylinder also has 4 quadrants that are color-coded. 3 race cars must land in the rotating quadrant whose color corresponds with the assigned starting position to the team. The final task is to lift a rocket a minimum of 42 inches or for full points 100 inches. Total egress means all parts of the robot end up within the highlighted region of the track. A total egress triples the number of points for getting the cars in the correct quadrant.
Our robot's base was made almost completely out of wood. When drafting it, we wanted and even bought aluminum bars to make a frame. Once we tried to build it, we saw how difficult it was to put together, and that we had no real reason to use aluminum over wood since the wood was so much easier to cut to the correct size. We bought 7-inch wheels for the rear, PVC, and an aluminum rod to drive the robot. The PVC was cut in 1-inch pieces and fit into the wood to act as a sleeve for the axles. The axle was fixed to the wheels by hot glue and acrylic to ensure it would not slip. To drive the wheels, we later cut gears out of wood and fixed them on the ends of the axles. We used wood glue to attach all of our wood together and screws to bond anything that went from metal to wood. Out of our mechatronics kit, we used 1 motor to drive the robot, 1 motor to lift the rocket and pulley system, the pneumatics to hit Buzz back, and the solenoid to release the gate for the cars.
Now for how our robot works. Our robot moves to the center with a drivetrain specially designed to avoid the aliens and allow for easy retrieval of Buzz. There are 2 fixed wheels at the front and a gear system at the back. The motor in the blue case drives the gear connected to the top axle. The top axle drives 2 bottom axles, allowing for an open underside. 2 free spinning washers at the front provide a rolling contact with the centerpiece. This allows for the robot to sit close to the cylinder legally and keeps the front away from protrusions shown here. To identify when to release the cars into the quadrant, a switch mechanism is used. The switch is placed in the correct color before the round begins. The switch is hit by a protrusion on the cylinder which is at a height corresponding to the color. The switch activates a solenoid to release the cars by a drop gate. The acrylic gate sits on a pin, and when the pin is pulled into the solenoid, the gate falls. The Buzz retrieval system was the most difficult to perfect. The linear actuator triggers once the robot is in position. This pushes the mousetrap down behind the block. When it reaches the bottom, a cord attached to the release of the mousetrap pulls taut and triggers. The trap hits the block backward toward the start zone. This is why an open axle at the back was necessary, to allow the block a clear exit. Our rocket system is the most reliable. It uses a system of drawer slides and pulleys. A motor turns the spool which winds the string attached to the pulleys, lifting the rocket the minimum 42 inches.
Surely this is it!
Someone got disconnected.
Yes!
While building this robot, we faced challenges with each of the tasks. One of our priorities was to make the robot perform a complete egress. To do so, it had to have a clearance above the height of the aliens. This is the driving factor for why we had to use gears and a drivetrain system as opposed to simply driving it with a straight axle. When trying to retrieve Buzz, our mechanism was not adjustable, and relied on exact measurements to successfully retrieve the wooden block. This was an issue when we competed because the track was just different enough to cause our Buzz retriever to fail. fix this, we cut slots in our robot which allowed us to slide the buzz retriever forward or backward depending on the track. Our original idea to lift the rocket was to use a scissor lift. After constructing it, we quickly found that it took a lot of initial force to get the lift started, and our motor simply did not have enough power to do so. Our next idea was to use drawer slides and a pulley system to suspend the rocket. After constructing it, it seemed to work flawlessly, but in the competition, the slack in the pulleys caused our robot to measure in at just under 42 inches. After the competition, we bolted our pulleys down and consistently reached 46 inches. To deliver the cars, we used a ramp with a timed gate. The timing was based on a switch being hit by the pegs off the rotating centerpiece. We had one failure of the switch not triggering, and in a hurry to fix it, we placed a piece of metal on the end. The metal caused it to trigger on the wrong color, scoring us 0 points. This was a very simple fix that just needed a smaller piece of metal on the end of the switch. The ramp worked flawlessly, but the gate had some friction issues in the beginning. We originally made it out of wood, and after a few tests, we saw it would not consistently drop the gate. We then switched to an acrylic gate, and it had no failures deploying the cars. Some design improvements we think would enhance the overall performance of the robot include using similar sized wheels on the front of the robot, maximizing space on the inside of the robot, and giving it a paint job. The larger wheels for the front will assist in driving the robot with better precision, as we had issues with it not stopping where we wanted it to. It will also improve the overall aesthetic of the robot, giving it a very sleek design. We want to maximize the space on the inside of the robot because it began to get crowded and difficult to work on anything inside the robot. We would do this by constructing more walls and attaching more components to the walls as opposed to the base of the robot. Giving the robot a paint job would make the overall design look more professional. This would ideally be done before constructing the robot to avoid any parts no longer fitting together. With these improvements, we believe our robot would score well in the design review category as well as in the final competition.